Okay, chain rule. I would highly recommend to write down somewhere all these formulas because we are going to use them. And this is a main set of all of the rules for derivatives. Therefore, take a minute, write down them, so that will be very helpful for you. All right, I will move on, but you can put it on the pause and write these formulas down. Let's understand what is a chain rule. Why do we use chain rule? Here I found a picture of 1, 2, 3, 4 gears. So imagine that those are some parts of some machine or equipment. The gear 1, let's say, rotating 3 times faster than gear 2. And gear 2, let's say, is rotating 4 times slower than gear 4. And then gear 3, 2, and 4 also working also together, so at the different speed. So to express this, but for engineers to design it, they have to go through derivatives because chain rule is the one providing the different speed, velocity of these gears. Okay, so just to repeat one more time, first derivative provide velocity, that's speed, which is scalar value, plus direction. Okay, so and the chain rule, when you have more than one gears expressed in mathematically, to show how they work together. Okay, so let's look at the math part now. In what case we are going to use chain rule? Let's say for the case I have on the left side, left column, the functions that you can take derivative without chain rule. Like say first one, y is equal x squared plus x, but at the second I put here, let me use this color, and at the second I put here square root, right? We are going to use chain rule. Why is that? Because first I have to take derivative of square root and then get inside to take derivative of x squared plus 1. So here we can imagine 2 gears. Square root is 1 gear, and inside x squared plus 1 is second gear. Next, number 2, let's say y is equal sine x. So that's all right. We can take derivative, and we don't need chain rule. Chain rule meaning several different derivatives. So, the derivatives of different parts of the function. That would be better way to explain. So chain rule, applying derivative to different parts of the same expression or function. So let's see. When we have y is equal sine x, we don't need any chain rule. So derivative of sine x is negative cosine x, right? But at the second, I put 6x instead of 1x. So it's gonna go under chain rule because first you have to take the derivative of sine x, and second you have to take derivative of 6x, because as you can see, original function is x, but we have here 6x. Or another example, if we have sine squared x, right? We know derivative of sine x, but now here we have to take derivative of square also. All right? So that's a chain rule. Next, we have 3x minus 2. You don't need any chain rule. Take derivative of 3x, which is 3, and derivative of 2 is 0, so you get 3. But different story when this 3x minus 2 put in parentheses and raised to power 5. So here we have to take derivative of 5. First we take derivative from outside, and then we get to derivative from inside to inside. See, again, 2 gears, power 5, and then we get inside and take derivative of 3x minus 2. And the fourth example, we don't apply chain when we have x plus tangent x. We just apply the derivative, sum of derivatives, derivative of x and then derivative of tangent x. But here, on the left side, I have tangent x squared. So instead of tangent x, I have x squared. That brings me to chain rule, which means first I have to take care of derivative of tangent x squared and then move to the derivative of x squared. Okay? That's the difference between chain rule and the no chain rule. So one more time, chain rule we apply to different parts of the same equation, the same expression of the function. Okay, now let's work on it. Let's solve quite a few problems. I have prepared all cases. I think there are about 16 cases, but all of them we need to cover so we can understand they apply to different cases. So y is equal x squared plus 1 to power 3. If I would have x squared plus 1, I'll just would take derivative x squared, derivative of 1, and I would be done. But I have x squared plus 1 to power 3. So that means I'm going to take first the derivative. Let me write down. D by dx x squared plus 1 to power 3. That is equal. I'm going to take first derivative of x squared plus 1 to power 3, yes, which is going to be equal 3 times x squared plus 1 to power 2, because I imagine x squared plus 1, let me do here some drafting, x squared plus 1 to power 3. This I can represent x squared plus 1, represent with k, let's say. So therefore, if I want to take derivative d by dk and put here k cubed, it's going to be 3k squared, right? Okay, the same way I have x squared plus 1, 3 times, this 3 comes in front, and we have 3 times x plus 1 to power 2. And only then we multiply by derivative of x squared plus 1. Getting inside and multiply by derivative x squared plus 1, which is going to be 3 times x squared plus 1 squared, and times derivative of x squared is 2x, derivative of 1 is 0. Therefore, it's going to be equal 6x and x squared plus 1 squared. Okay, next one. Y is equal 3x minus 2x squared to power 4. Because my expressions or function built based on x, therefore I put d by dx. Let me tell you something. Let's say I have 3x minus 2xy over 4. If by chance I would put, instead of x, I would put d by d, let's say what? dt for 3x minus 2x squared to power 4 and take derivative, the result would be the same. It would be 3x minus 2x squared to power 4. Why is that? Because we want take derivative by t. And in this function, I don't have any t there. It's all x, right? Which has nothing to do with t. Therefore, this function is not going to be differentiable. And we leave it alone. So here, 2, I forgot. Okay? Now, that's why I'm going to differentiate by x. Then it could be completely different story. So I'm going to take derivative of this entire parenthesis first, which is it's gonna be, let me, taking derivative of this 4 here, right? It's gonna be 4 3x minus 2x squared. Instead of 4, I will have left 3, right? 3. And times, now I'm getting inside and taking derivative of what I have inside. So derivative of 3x, it's going to be 3. And derivative of 2x squared, it's going to be 2 times. This exponent 2 come in front, right? And x to power 1. Let me remind you, very often we are going to use the formula x to power n. Derivative is going to be n times x to power n minus 1. And that's exactly what I did. This 2 came in front, right? Here it is. And 2 minus 1 is 1. And we have 1. So the final answer is going to be 4 times 3x minus 2x squared to power 3 times 3 minus 4x. Okay? Next one. F of x is equal cubic radical for x squared minus 1 to power 2. So I'm going to rewrite because there is no derivative for radical per se. Therefore, I'm bringing to the format where I can apply this formula, this rule of derivative, which is going to be, I'm going to write down x squared minus 1 and raised to power 2 over 3, 2/3. Yes? So, what we're going to do now, derivative is going to be equal f prime of x. It's going to be equal, first I'm going to take derivative of this 2/3, which means this derivative is coming in front, and I will get 2/3 x squared minus 1, and 2/3 minus 1, it's going to be 1/3, negative 1/3. For people, for students who are having trouble with addition and subtraction of fractions, I will put the reference to the video how to add and subtract simple fractions. Okay, we took the derivative of 2/3. Next, we are getting inside, and then we take derivative of inside of parentheses. So derivative of x squared is going to be 2x, and derivative of 1 is 0. So if I multiply, 2/3 multiplied by 2x, it's going to be 4 over 3x, and x squared minus 1 to power negative 1/3. Because we have negative, it's going to look like 4x over 3, and we will have here cubic radical. Let me move this 3 a little bit ahead and to make sure. Okay, and that will be equal cubic radical x squared minus 1. Okay? All right, moving to next one. g of t is equal negative 7 over 2t minus 3 squared. So this division, I'm going to, okay, this division I'm going to flip into multiplication. Therefore, I'm going to write down negative 7 times 2t minus 3 to power negative 2. So now I will work with multiplication instead of division. And if by chance I write down if I write down d by dx, let's say, of this function, then it won't be differentiable, right? Because this function has t as a variable, and I'm trying to take derivative by x, based on x. Therefore, I can't do anything, and the entire function will come out with no change. Therefore, we need to take derivative by t. Okay? For negative 7 times 2t minus 3 to power negative 2. Okay. So, look what's happening here. We are going to apply the rule of multiplication, right? And chain. So, within, in multiplication, in the rule of multiplication, we have also rule of chain. Where is the rule of chain? Here it is. We have negative 2. It's not only 2. If I would have only 2t minus 3, then I would have just the rule of multiplication. But because we have all to power negative 2, in that case, we will have chain rule. Okay? So, we can apply rule of multiplication, but since we have here constant negative 7, then I can use constant multiple rule. And constant multiple rule says derivative by x. Let's say here I will have c f of x. It's going to be equal c. That's a constant, will come out. Why is it constant? Because related to x, it has nothing to do, right? They don't have anything in common. This is what I'm talking all this time. It has to be the same variable to take derivative. Okay? Therefore, that constant comes out negative 7 negative 7 will stay as a constant. Oh, I didn't finish it. So it's going to be d by dx of function f of x. Okay, so negative 7 was going to stay there, and I have to take first derivative of this negative 2, right, which will come in front, will be times negative 2t minus 3 to power negative 2 minus 1 will be negative 3, and then only multiply by derivative in the parentheses, which is going to be derivative in parentheses, derivative of 2t, it's going to be 2, and derivative of negative 3, it's going to be 0, right? Okay. Hold on, I put these derivatives. Let me move it down right here. Okay. And that is equal. So negative 7 times negative 2 is going to be positive 14. And 14 times 2, it's going to be 28. 28 times, okay, since we have here power negative 3, this is what I'm going to do up front. I'm going to bring down this power negative 3, will be power positive 3, and 28 I put in the numerator, and denominator I will have 2t minus 3 to power 3. And I am done. Okay. Question number 5. So question number 5, before I take a derivative, I'm going to represent a square root in the format of a rational exponent, which is going to be x squared times 1 minus x squared to power 1 over 2. Yes? Now let's take derivative. So f prime of x, I'm writing down this way, it's easy. So it's going to be equal. Now here, see, in the previous case, we had -7 times, where -7 is constant. That's why we could take out. But here, there is no avoidance. We have x squared, and we have multiplied by this. May this half put higher, so it won't be, looks like multiply. There we go. So we have in both the terms, we have x's. So we really have to apply the rule of multiplication, and involved also will be chain rule because of this. Okay? So let me drag this down. What was the rule of multiplication? When we have derivative d by, we move this down, it's coming too crowdy. Okay, d by dx for f and g is equal. Well, we assume both of them, both functions f and g are differentiable, and they depend on x, both of them. So it's going to be equal f derivative of f multiplied by g, and plus derivative of g multiplied by f. That's a rule of multiplication, and we are going to use that rule. So this is equal. First we are taking, it's going to be derivative of x squared, right, times 1 minus x squared to power 1/2. Let me put under more angles so we will know it's a derivative, otherwise you might take it as a 1. And then plus derivative of 1 minus x squared to power 1/2, and it's going to be derivative of that, and multiplied by x squared, right? Okay, so x squared is f, and 1 minus x squared to 1/2, it's going to be g. Let me write down, this is f, this is our f, this is our g. All right, so let's simplify. What do we get? Derivative of x squared is going to be 2x, right? Times 1 minus x squared to power 1 over 2. And then plus derivative 1 minus x squared to power 1/2. It's a chain rule. So first I have to take derivative of this 1/2, which is going to come in front, right? And I'm getting 1/2, 1 minus x squared, 1/2 minus 1, going to be negative 1/2, right? And then getting inside of parentheses 1 minus x squared. Derivative of 1 is 0. Derivative of x squared is going to be 2x. So we are going to have negative 2x. And multiply by this x squared. So the result is going to be is equal to 2x 1 minus x squared to power 1/2 plus, what do we have? See, 1 minus x squared to power negative half, which is going to be 1 over 2. It's 1/2 is a square root, right? 1 minus x squared, and multiplied by negative 2x. Since we have negative 2x, and might as well, instead of this plus, I can put minus. Here will be 2x, and then times x squared. So now let's simplify. Common denominator is 2 square root 1 minus x squared, yes? So which means for this fraction, for this term, 2x square root 1 minus x squared, I'm going to divide and multiply the common denominator, so which is going to be twice. Oh, this is too thick. Twice square root 1 minus x squared, and same thing here, times twice square root 1 minus x squared, and minus, now here we get 2x cubed over 2 square root 1 minus x squared. Okay, so what do we get from here? It's equal 2 square root 1 minus x squared. So I'm going to combine. So 2x times 2 here, 2x times this 2, I'm getting 4x. And then times 1 square root 1 minus x squared times square root 1 minus x squared. It's going to be 1 minus x squared, right? Getting out of square root, yes? And minus 2x cubed. Okay, let's open parentheses. 2 square root 1 minus x squared. We get 4x, I'm going to distribute, right? 4x minus 4x cubed and minus 2x cubed. So what is going to happen here is equal 4x minus 6x cubed over 2 square root 1 minus x squared. All right. This is equal. I'm taking 2 out. 2x minus, 2x I'm taking out. It's going to be 2 minus 3x squared, right? Over 2 square root 1 minus x squared. And 2 and 2 I will cancel, right? And the final answer is going to be x times 2 minus 3x squared over square root 1 minus x squared. Hallelujah. We finally finished. So I'm going to post this video. This topic is going to be in 2 parts, consist of 2 parts. So I will post this one, and then in the next video I will do examples with trigonometric functions. Okay? See you in next video. Bye for now.